Determining the budget is the process of aggregating estimated costs to establish an authorized financial baseline for the project. Now, let's talk about determining the budget. This process involves aggregating all the estimated costs of individual activities or work packages to establish an authorized cost baseline. It's not just about adding up numbers, it's also about creating a time-phased project cost, meaning costs are mapped over the project timeline for better control and forecasting. As shown in the table, we rely on inputs like the project management plan, project documents, and business documents. We use tools like expert judgment, cost aggregation, and reserve analysis. The outputs include the cost baseline, project funding requirements, and updates to key documents like the project schedule and risk register. When determining the project budget, we start by reviewing key documents, the cost management plan, human resource management plan, and the scope baseline, which includes the project scope statement, WBS, and WBS dictionary. We also factor in enterprise environmental factors and organizational process assets. Next, we check the project schedule to understand the type, quantity, and duration of resources needed. We also review the risk register to account for any risks that might impact costs. Once all that information is gathered, we apply the appropriate tools and techniques to structure our budget properly. We also make sure we understand the project's funding requirements and cash flow needs to keep the project moving. Finally, we document the project budget, create the cost baseline, and update project documents as needed. Now, let's talk about the cost baseline. The cost baseline is essentially the approved version of the project budget, excluding any management reserves. It is based on the base estimation, the authorized funds for spending on the project. Importantly, it includes all estimated costs and contingency reserves, but does not include management reserves. This baseline becomes the benchmark we use to monitor and control project cost performance throughout the project. When it comes to cost estimating techniques, we have several options based on the project's needs. Analogous estimating is fast and simple, using past projects as a reference. Its advantage is that no work is omitted, but the downside is that it can be difficult to match projects accurately. Bottom-up estimating is very accurate and itemized because it breaks work down into smaller pieces, though it can be very time-consuming. On the other hand, parametric estimating uses mathematical models and historical data, making it fast and efficient, especially with the help of tools like the project management information systems. However, the results depend heavily on the integrity and accuracy of the input data. Choosing the right technique depends on balancing speed, accuracy, and available information. This diagram shows the buildup of the project budget step by step. We start at the bottom with activity estimates, the costs of individual activities. These roll up into work package estimates, like work package 1, work package 2, and so on. Work package costs are then aggregated into control accounts, CA1 and CA2 in this example, giving us a structured view of spending. From there, we add up all control account estimates to form the project estimate of $1,250. Next, we add contingency reserves, planned buffers for identified risks, bringing the total to $1,355. This forms the cost baseline, the approved budget for project execution. Finally, if needed, management reserves are added separately for unforeseen work, resulting in the total cost budget of $1,423. This graphic shows how cost baseline, expenditures, and funding requirements interact over time. The cost baseline, the solid curved line, represents the approved budget for project work, excluding any management reserves. As work is performed, expenditures, the dotted line, rise over time, tracking actual spending. Funding requirements, shown as a dashed step line, reflect when funds are needed to support work, ensuring the project never runs short of cash. Above the baseline sits the management reserve, a buffer for unknown risks. Adding the management reserve to the cost baseline gives us the total project budget. And finally, the term BAC, budget at completion, marks the total expected baseline cost once the project is finished. Once the project management plan is baselined, any proposed changes must be carefully evaluated. The process starts by submitting a change request, which is formally documented and reviewed. Not every change request gets approved. Some are rejected if they conflict with project goals or constraints. If a change request is approved, it triggers updates to the project management plan and possibly to project documents as well. Throughout this process, it's important to maintain tight control over communications. Stakeholders must be informed about proposed changes, their potential impacts, and final decisions. Change management ensures that projects remain aligned with their original objectives, or that any shifts are deliberate and well documented. Without this structure, changes could easily cause scope creep, missed deadlines, or cost overruns. In an ideal project, the budget is carefully set during the planning phase and remains stable throughout the project's life cycle. However, we know that projects rarely exist in a perfect environment. New or changing requirements, the emergence of new risks, or shifts in the probabilities and impacts of existing risks can all challenge the original plan. Economic factors, procurement changes, or unexpected resource costs can also lead to adjustments. As these challenges arise, the project manager must be prepared to reassess the financial and resource needs of the project. When changes occur, it often becomes necessary to adjust one or more core elements of the project, the budget, the overall cost, the schedule, or even the project scope. Each adjustment has a ripple effect across the project's planning and execution. Proactively identifying these challenges early and maintaining flexibility allows the project manager to manage expectations and keep the project aligned with its strategic goals. When a change request is submitted, it's important to evaluate alternatives by identifying their strengths and weaknesses. A thorough analysis helps the project team determine if the alternative solution offers real benefits or simply introduces new risks. Factors to consider include the impact on scope, cost, and schedule, as well as the technical feasibility and overall alignment with project goals. Evaluating alternatives also brings transparency to the decision-making process. Stakeholders can clearly see the trade-offs involved and understand why a particular path was chosen. By systematically reviewing the pros and cons, project managers ensure that changes are implemented thoughtfully, preserving project integrity while adapting to new challenges. When evaluating a change request, it's important to assess whether the outcome is worth the investment. This means considering not just the immediate benefits, but also the long-term value relative to the resources, such as time, money, and effort, that must be committed. If the improvement is marginal compared to the resources needed, it may not be a sound decision to proceed. A relative comparison can help prioritize multiple requests or alternatives. By weighing the expected outcome against the effort invested, project teams can focus on changes that offer the highest return on investment. This approach ensures that decisions are strategic, resource efficient, and supportive of the project's overall goals. When planning for future financial needs, it's important to understand the concept of present value. Present value helps you determine how much money you need to invest today to reach a specific financial goal in the future, accounting for the expected rate of return. The formula shown here discounts the future value based on the interest rate and time, giving you the amount you should invest now. For example, if you need $3,000 in 3 years and can earn 8% interest annually, you will only need to invest $2,381.50 today. By applying the present value formula, we see that the money will grow over time to meet your future need, emphasizing how powerful early investment can be. When evaluating investments or projects, net present value is a key tool we use. NPV measures the difference between the present value of all cash inflows and the present value of all cash outflows over time. It helps us understand if a project will add value to the business based on today's dollar value. A positive NPV means the project is expected to generate more value than it costs, making it a good investment. A negative NPV suggests a loss, and typically the project would be rejected. Simply put, NPV tells us if the money we invest today will grow into something worth more in the future. There are several advantages to using net present value when making investment decisions. First, NPV accounts for the time value of money, meaning it recognizes that $1 today is worth more than $1 in the future. It also uses all of the cash flows throughout a project's life, not just the first few years, giving a complete picture of profitability. However, NPV does have some limitations. It relies heavily on estimates, like future cash flows and discount rates, which can introduce risk if predictions are inaccurate. Plus, it may not easily compare projects of different sizes without adjusting for scale. Even with these challenges, NPV remains one of the most reliable tools for investment evaluation. Monte Carlo simulation is a powerful analysis technique where a computer model is run many times, each time using randomly selected input values based on probability distributions. The goal is to generate a wide range of possible outcomes for a project, helping to understand potential risks and variations. It's important to remember that Monte Carlo isn't just one method, it's a whole family of techniques that use random numbers, probabilities, and algorithms to model uncertainty and predict results. When multiple approaches are possible, project teams often turn to A/B testing to find out which option users prefer. In A/B testing, different groups of users are shown slightly different versions of a product or service, usually with just one change, called the independent variable. By analyzing the user's reactions, we can optimize our solution based on real user preferences, leading to better results and experiences. When managing projects, uncertainties can come from many sources, such as variations in cost and schedule, different team performances, unexpected external factors. Rather than looking at each uncertainty separately, we combine them to see their overall effect. This helps us better understand the full range of possible outcomes and prepare smarter strategies to manage risks. Cost control demands rigorous oversight and intervention throughout a project's life cycle to ensure that financial resources are used efficiently and objectives remain achievable. It requires vigilant monitoring of spending trends, quick detection of variances, and decisive corrective action to eliminate waste, safeguard profitability, and protect the integrity of the original project plan. Effective cost control transforms raw financial data into actionable intelligence, utilizing sharp analytical tools to trace, forecast, and regulate cost performance aggressively. It empowers project teams to tighten their grip on financial outcomes, ensuring that every dollar spent directly contributes to delivering project value without erosion of scope, quality, or deadlines. In project management, controlling costs is all about making sure we stay on budget. We use a variety of inputs, like the project management plan, cost baseline, and project documents, to guide us. Then, through tools and techniques such as data analysis and earned value analysis, we track and evaluate performance. This process gives us key outputs: work performance information, cost forecasts, change requests when necessary, and updates to project plans and documents. Key concepts we track include planned value, how much work we should have completed; earned value, how much work we've actually completed; actual cost, how much we've spent so far. By comparing these, we can spot any cost overruns early and take action before small problems become big ones. To monitor project performance, we use variance calculations based on planned value, earned value, and actual cost. There are 4 key formulas. Schedule variance tells us if we're ahead or behind schedule. It is equal to earned value minus planned value. Cost variance tells us if we're under or over budget. It is equal to earned value minus actual cost. Schedule performance index measures schedule efficiency. It is equal to earned value divided by planned value. Cost performance index measures cost efficiency. It is equal to earned value divided by actual cost. In short, planned value is what we plan to achieve. Earned value is what we accomplished. Actual cost is what we spent. Now, let's break down what the cost variance and cost performance index numbers actually tell us. Cost variance measures the difference between what we expected to spend and what we actually spent. A positive CV means we are under budget, good news. A 0 CV means we are exactly on budget, rare but possible. A negative CV means we are over budget, a warning sign to act. Cost performance index measures cost efficiency. A CPI greater than 1.0 means we are getting more value for our money, very efficient. A CPI of 1.0 means we are exactly on track, efficient but no margin. A CPI less than 1.0 means we are spending too much for the work done, not efficient. Both CV and CPI help us catch cost issues early, so we can adjust and keep the project healthy. Here's another quick snapshot of project health using 2 dimensions, cost and schedule. For cost, if CV is greater than 0 and CPI is greater than 1, then you're under budget, great news. If CV equals 0 and CPI equals 1, then you're right on budget. If CV is less than 0 and CPI is less than 1, then you're over budget, something to address. For schedule, if SV is greater than 0 and SPI is greater than 1, then you're ahead of schedule. If SV equals 0 and SPI equals 1, then you're on schedule. If SV is less than 0 and SPI is less than 1, then you're behind schedule. By combining these 2, you can quickly see if your project is ahead or behind schedule and over or under budget at the same time, and act accordingly. Now let's move into forecasting project outcomes with a few key terms. Budgeted completion is simply the total budget planned for the project when it's fully done. Estimated completion is the current updated forecast of what it will cost to finish everything. Estimate to complete is the cost needed from today forward to finish the remaining work. Variance at completion tells us whether we expect to be over or under budget when the project wraps up. If VAC is less than 0, we're forecasting over budget. If VAC is greater than 0, we're forecasting under budget. Finally, the to complete performance index shows how efficient we must be going forward. If TCPI is less than 1, completing within budget is easier. If TCPI is greater than 1, we'll need to work harder to stay within budget. In short, these tools help us predict where we're heading, not just where we are right now. Thank you for your unwavering commitment to excellence and your dedication to mastering the profession. We wish you resounding success on your path to certification.